Okay, now we're moving on to quadratic functions. They look just like some of the stuff that we've been dealing with. I'm sorry, that light shines right on that really bad. There's 3 different forms. The first form is standard form, where it's ax squared plus bx plus c, ABC. We've talked about that before. We're used to seeing that a lot. What's nice about standard form, this number right here, is my y-intercept, okay? So if I was going to graph it, I could tell you where my y-intercept was, okay? All right, that's the advantage of standard form. Plus, we're used to seeing it. We'll talk about that in a minute. All right, vertex form. As the name suggests, its advantage is I can find the vertex. The vertex in this case are these 2 numbers right here. I just have to change the sign of that, so my vertex would be at 4, 3. Now, vertex, remember, is the point where it changes direction. Since this is positive, I know it opens up, right? And my vertex is at 4, 1, 2, 3, 4, and 3, 1, 2, 3. So my vertex would be here, and it would open up something like that. Okay, I'll just kind of draw on it real quick. So that's the advantage of vertex form. The last one is factored form, and we've looked at that before. Remember when we factored and figured out where our zeros were? That's also where it crosses the x-axis. So the factored form is nice because I can quickly tell you where it's going to cross the x-axis. And they would cross the x at 4, 0 and negative 2, 0. Because you remember I set each one of these equal to 0 and solved. Do you remember that from before? So x minus 4 equals 0. Add 4 and I get 4. X plus 2 equals 0. Subtract 2, right? So x equals negative 2. So that would be where it crosses the x-axis. So if I was going to draw it, kind of just a freehand sketch, negative 2 and 1, 2, 3, 4. And I know it opens up because it's positive, so it looks something like that, right? Okay, so that gives you an idea of the advantage of each one. Most of the time, you're going to deal with either vertex form or standard form. So let me walk you through standard form real quick. Let's say I'm given this and they want to know where the vertex is, okay? So the easiest thing to remember with standard form is I always use this. X equals negative b over 2a, okay? So remember from before, this number here is a, this number here is b, this number here is c. I really don't need to know that, do I? So in this case, x equals negative b is 4, so negative 4, over 2 times a, which is 1, right? So then negative 4 divided by 2 is negative 2, right? So now I know the x value. Well, all I have to do now is plug negative 2 back in everywhere I see an x and solve. So y would equal x squared, but instead of x, I'm putting negative 2. Don't forget your parentheses when you're squaring. Plus 4 times negative 2 minus 32. Now, negative 2 squared is 4. And you can put this in the calculator. It'll do it all for you. And then 4 times negative 2 is minus 8 and minus 32. So that together is minus 40, right? So 4 minus 40 would give me negative 36. So my vertex on this one would be negative 2, negative 36. Which will be like way down, right? Here, way down here somewhere, and then it'll open up, right? Okay? So you get the idea. That's how you would find the vertex, okay? So negative b over 2a is your friend. Once you find that, plug it back into the original equation. If we're seeing x, put whatever number you got for the negative b over 2a and you're done. Okay, so that's a lot. And then, of course, we have our y-intercept. Okay, now if you really wanted to sketch a graph, well, let me do a different one over here. Maybe not quite so big of numbers because I don't want to go all the way down to negative 36. Okay, let's say I have y equals x squared plus 3x minus 4. Okay. Now, another thing you can do, I mean, we can go through and do the vertex, but sometimes I want to know some other points too. So remember, vertex, let's do that first. X equals negative b over 2a. And in this case, b is 3, so negative 3 over 2 times a, which in this case is 1. So I get negative 3 halves, okay? I can get a fraction, okay? Leave it as a fraction if you can. All right, then I'm going to plug it back in. So y equals negative 3 halves squared plus 3 times negative 3 halves minus 4, okay? So y equals 9 fourths plus, minus 9 halves minus 4. Okay, now, calculator would do all the math for you. That would be 18 over 4, and that would be 16 over 4. So 9 minus 18 is negative 9, minus 6 is, or minus 16, that'd be negative 25 over 4 would be my thing. So I would have negative 3 halves, negative 25 over 4 would be my vertex. See how sometimes it might be a little crazy, but that's okay. All right. If you need to know any other points, like if you need to know 3 other points, you can pick any value you want for x, plug it in, and see what y is, okay? Because it's an input-output type thing. So let's say you make x, I usually do like negative 3, negative 2, negative 1, right? And then get some values, and then I can kind of mirror it over. Because remember that vertex, you have the axis of symmetry too. And I'll talk about that in just a second. So if I plug in negative 3, I'd say negative 3 squared plus 3 times negative 3 minus 4. You get the idea, right? So that'd be 9 minus 9, which is 0, minus 4 would be negative 4, right? And then negative 2, plug that in, right? You just keep plugging in different numbers. So that's 4 minus 6 is negative 2, minus 4 is negative 6. And then if I plug in negative 1, right? See how I'm just changing that number for whatever x is. So that's 1 minus 3 is negative 2, minus 4 is negative 6. So you can see, if we remember correctly, our vertex is at negative 3 over 2, right? Which is halfway between these two. So I'm going to have that vertex sitting there, right? And that's a little over 6. So 1, 2, 3, 4, 5, 6. So here's 1, a negative 1, and negative 2. And then the vertex is sitting just a little bit below that, and then it would come up, okay? Do you get the idea? Okay, now, if they talk about axis of symmetry, that's just the line that cuts it in half and makes it a mirror image. And that's always your x value. So x equals negative 2. That would be my axis of symmetry, okay? Over here, x equals negative 3 over 2. That's going to be my axis of symmetry, okay? As long as the parabola is open up or down, it's going to be whatever your x equals, okay? And you know, if it's a negative, and if I change this to a negative, it'd flip the parabola upside down, right? Okay, that's if it's negative x squared. And if it's positive x squared, it opens up. That's pretty much the basics of quadratics.